All right, so this is more practice with the exact square roots. I've got a few more, and I want to talk about it. Well, how do I find those numbers if I don't know what they are? Okay, so if you were given a problem like square root of 180, and typically these show up the most often when you're doing Pythagorean theorem, but not always. There's other reasons you might get this, but very often these show up in Pythagorean theorem problems. And once again, if the instructions say give it in decimal form or to the nearest tenth or the nearest hundredth, you can just calculate that, and this would be a 13 point something because it's bigger than 169, which is 13 squared, so this is 13 point something. But if it says an exact square root, I need to figure out what this is. Now this is technically the exact square root, it's just not in simplified form. So I need to think about, okay, are there any hidden square roots in here? So there's two tricks here. One trick is you can say, all right, well, that's not a square root. Anything if that's divisible by 2, I can break that in half and just try all the roots bigger than half that. So half that is 90. So let me think about, okay, what's square root's big, less than 90? We've got 81. 81 doesn't divide into that. 64. That doesn't divide into that. 30, no, not 32. Next one down is 49. That doesn't divide into that. 36. Now, this may not be obvious, but that does divide into that. This is square root of 180. I'm sorry. This is square root of 36 times 5. All right? So square root of 36 times 5. That's square root of 36 times the square root of 5. So that's 6 square root 5. And if you want to verify to yourself that those are the same answers, do 180 square root in your calculator, then do square root of 5 times 6 in your calculator. Those should be the same thing. In fact, when you first start doing those, you might actually want to double check this and this get you the same answer, because otherwise you made a mistake along the way. All right, the other way you could have found that answer, and this is the way I typically do it. 180, I can factor this. I can say, oh, well, that's 18 and 10, however I choose to factor it. That's going to be 6 and 3. That's going to be 2 and 5. That's going to be 3 and 2. And then I start looking for my perfect squares. I'm like, oh, okay, 3 times 3, that's 3 squared. 2 times 2, that's 2 squared. And the 5 is left over. So when I take the square root of all that, it's 3 squared times 2 squared times 5. So when I bring that out from the radical, square root of 3 squared is 3, square root of 2 squared is 2, and square root of 5 is left underneath the radical sign. So that is the 6 square root of 5 I did. All right, I'm going to do one more example and I'm going to be done. So let's do 288, square root of it. So once again, two examples. That is not a perfect square because I know my perfect square is up through 15. Half of that is 144, so I'm going to look for squares less than that. So perfect square, oh, that is a perfect square. I got lucky the first time. If that was not a perfect square, I'd then try what the next one down from that, which is 121, and the next one down from that, which is 81. Need to know your perfect squares up through 15. All right, so this is 144 is a perfect square, so this is actually 144 times 2. So square root of that, that's 12 squared. So that comes out from underneath, and I'm left with square root 2. And once again, if I'm not sure if I got the right answer, I can check it in my calculator. Square root of 288 gives me a number, and then 12 times the square root of 2 should give me the same decimal number. The other way, once again, 288. If I want to, I can factor it. I'm going to show a different factoring method. This is the factoring method I learned, is I start with my smallest prime numbers and work my way up. So, okay, that divides by 2. That's 144. That divides by 2. That's 72. Make sure that's right. Yeah, that's right. Divided by 2. That's 36. That's just, I could do 6 times 6, but I'm going to continue it. I keep going down. 3. No, that's 2 again. It's 18, 2, 9, 3, 3. So I have all my factors there. So I got a 2 and a 2 and a 3 squared. So that's 2 squared times 2 squared times 3 squared with 1, 2 left over. That's not squared. So out front it's 2 times 3 times the square root of 2, and that's 12 square root of 2. If you're not comfortable with the staircase method, that's fine. Do it, the tree method. Do 288 and realize it's that. In fact, if you get to this point, if you start factoring this, oh, wait, perfect square, then you can stop. You can say 12 and 12. You can stop, but if you need to keep going to find all the pairs, you can do that. All right, I think that's enough. If you want to try one on your own, let me give you, I'll give you two more. Square root of 175, that's one of them. And the other one is square root of 363. So pause it right here and try those, and then I'm going to write the answers down for you. Did you pause it? Okay, so this basically factors to square root of 5 squared times 7. So that's 5 root 7. And this other one is 11 squared times 3. So that's 11 root 3. All right, that's it. Oh, yeah, I got to do my signature. Whoa, whoa, I was told by my algebra class I had to fall out of my chair every time. That would be like my signature move, and that'll be a viral YouTube sensation. See ya.